And last is transportation engineering. This is about safe and efficient movement of goods and people. These are the engineers who design streets, roads, highways, railroads, public transportation systems, and even airports. So maybe this engineer has to look at the kind of demand from a new development, whether it's a new stadium in your city, all the way to a new grocery store in a new location. This is going to cause new types of traffic throughout the area. The engineers would try to optimize how the new development impacts existing traffic. They would look at data from other similar places to see what kind of traffic they get, then try to make improvements where possible. It could be simple, like adding a bus stop in the nearby area, all the way to expanding the roadway to allow for more traffic. They could work on the geometrics of the roadway, such as what radius of curvature does an off-ramp have to be for a car going 55 miles per hour so the tires won't slip. Or if they're going up an incline, the driver needs to see far enough ahead of them to stop if there's a sudden obstacle. Or what do the cross sections of a freeway need to be for the lanes and the shoulders to accommodate the amount of traffic that's expected? Or let's say a highway interchange is being designed. A structural engineer would make it stable and design the structure itself, but the transportation engineer would determine maybe how many lanes are needed for the interchange based on traffic, or how the merging should happen to maximize safety. They make sure that the layout is designed to maximize traffic flow and safety rather than the physics of the structure itself. Often these engineers evaluate potential improvements to cities in terms of transportation rather than create a totally new design. As in, you probably haven't had many new highways put into your city in the last few years, but there's probably been plenty of construction, whether it be adding an express lane or a bike lane, etc. So they might not create a new bus transportation system, but they may optimize the existing one. Maybe they take data from how many people get on the bus, how long the bus takes to complete its route, how long people are waiting for the bus, and so on to optimize the route, the amount of stops, and more. Your career will also likely involve a good amount of computer work. You might have to create a layout of the new lane, off-ramp, bridge, or whatever you're designing on AutoCAD, which is a very important software for civil engineers. Or you could use software to analyze and simulate traffic. You could actually lay out the roadway of a city and use collected data of traffic during different times of the day and simulate new additions. Like you could add in a stoplight somewhere and see what the new traffic would be like. Or you can make a minor change, like make a certain stoplight stay green for just a few seconds longer and see how it affects traffic on those streets. And just note, this is not a very math-heavy field. In fact, it's probably the least math-intensive of the 4 subdisciplines I've talked about. It's more about taking data and analyzing it. Even when I talked about the radius of curvature and how fast someone should be going, you won't use the coefficient of friction and do circular motion physics or anything like that. You use even simpler equations to get what you need. Now that's all the main subdisciplines of this major, but there are some final thoughts I want to include. If you're watching all this and are more interested in the artistic aspect of building and structure designs, then architecture will be better for you.